Hello everyone, I'm Chung-Yi, nice to meet you. I want to use Construct 3, making a horizontal aircraft game. I never tried this kind of game before, so I just try it with my previous knowledge of Construct 3. It took a week or two. Finally, I finished this proof of connect. Take this opportunity. I'd like to share with you what I faced problems during the making of this game and encountered and solutions. I will adjust the previous video presentation for Construct 3 game production. As I shared before, I always show the flowchart of the game first, and then indicate which action corresponds to which step of the process, and I would provide the source code at the end. You could download source codes if you interest in them. But then I thought about it many times. I always felt that this way of sharing, not the last thing I wanted to present. It's like when I was working on this game, I have already known how to do each step. But actually, I tried to modify a lot of features times by times. Then you can see the result in the end. So, the presentation way of this time, I will focus on when I made this game. How do I think about the logic? And what problems have I encountered? It might be less structured. You may also feel chua when you're watching this video. You could get what my ideas related to my actions. Maybe it's the better way to get what game making is all about. Okay, I hope this way could help you more when you also try to make a game. So back to the topic. When I want to make a horizontal aircraft game with C3, what should we considering? First of all, of course, I need an aircraft. You could choose circle, square, triangle, or a little demon if you like. I'll select the triangle here. I always make these little sprites in prototype layout. It could help me to see it all at once. After the aircraft has been built, I will check animations, observe if it has the correct collision area. Here is a simple geometry. And C3 will be a very clever guess what their collision area. In generally, if they don't have very complex graphics, the C3 would have a wrong guess. If you don't feel good with this guessing area, you can also adjust it by yourself. There are 5 or 6 boundary points by default. You can also add more nodes. But be aware of the following. The system will hint you that more nodes will cause the performance to decrease. Here, you need to think about what you need. And then, the flying area. The horizontal flight game usually have a very long forward area. And then the viewpoint will follow the player. And then gradually moving forward to the next area. So we're going to increase the size of the main layers in horizontal into a very long bar. Then I want to design multiple layers. Roughly, there are UI, bullets, players, enemies, scene obstacles, and background images. In visually, no matter how much T-forwarding, UI layer should remain in the same position. Here's how to set the specific settings. The scroll rate of that layer, in parallax, should be set to 0%. After setting it this way, no matter how much the player forwarding, his aircraft will stay in the center, and would not run around. Then there are bullets, players, enemies, and scene obstacles. The basic concept of these layers is, the upper layer sprite will cover the lower layer sprite. Who goes up, who's down, depending on what your needs, you can decide for yourself. Then there's the background layer. The behavior of this layer is very similar to the UI layer, but it's not quite the same. We would expect the background layer will move forward when the user forwarding. But the background doesn't move forward as much. At this point you can set this parameter. Its x-axis is set to 15%. The width of the background layer is about 10,000 px. So the background image provides about 3,000 px in really. Anyway, you'll know the number around 3K. In actuality, I didn't understand how it works. But I got these parameters by try and error. So in your game, if you want to achieve this effect, you might have to try and error adduced parameters in your game. I'm going to run this game here. Based on my developing, I'm constantly running tests during the development to make sure that my game design concept is correct. As you can see now, it's an aircraft. There's no other things. So the first step I have to take is how to move the player to the right at a fixed speed. This can be achieved with bullet behavior. So I added a bullet behavior to the player's prototype and set the relevant parameters. Run it again and see. You'll see that the player moved to the right. Okay, I know what you think. The player disappeared in a couple of seconds. I'll fix this part right away. The main reason for this problem is that you don't have a camera set. The behavior of the camera, scroll to, can be added to any sprite. If we add this to the player, then the viewport will move forward with the player position. But I refuse. I won't do that here. Because later I want to design a multiple players game. Lots of players on the same screen. So the camera shouldn't get stuck on a single player. So we should design a third-party sprite. With the property of the camera, scroll to. It moves forward at a quantitative speed, and force the player to keep up. This would be more reasonable. I created a little sprite for this camera. Then assign the scroll to behavior. This way the screen will keep moving with it. In the game scene, you can place the camera in manual. But I recommend putting it in the script program, created according to the conditions. For example, when the scene starts, then build this, it would be better. Next, the camera transparency is set to 30%. But actually, in general, you should set it to 0% in program. It could make the player can see this camera. Now look at the steady forward progress of the camera. But the player is likely to run out of this screen. This also is not a difficult problem. We can create a box in the UI layer. That's actually 4 bars. And set their behavior to solid, which is fixed in location. Then the player will not exceed this camera range, which the range of possible presentations. Back to the small aircraft. Now the little aircraft will move forward to the right side. But you can control it. If there is no interactive in this game, then it's not a game. It's just an animation. If you want to control this small aircraft, the easiest thing is to apply the 8-way behavior. And keep the parameters of default control to true. You can then use the keyboard arrow keys to control the direction of this aircraft. But I refuse. Here I have to turn off default control. I want to control it in my way. Because my default gaming device is probably a computer or a cell phone. The input control could also be a mouse or a touch panel. It could even be a joystick. Not just a keyboard. The default control way may not be supported all my needs. Now, I am going to explain my design concept. I want to design a group of variables. To record if the player presses up, down, left, right, shooting, and cannon keys. And the input sources can be keyboard, mouse and UI control panels. First double-click anywhere on the screen to add an object. Includes keyboard, mouse, joystick, and touch panel. In fact, in C3, these inputs are managed in a unified way. You don't need to create a prototype individually. So since they are created, you can access these functions later on. And then write the relevant program to trigger some things. The purpose of these codes is to allow the aircraft to follow these variables of the button to do some actions. Variables will be true or false, then the game will perform the corresponding behavior. This allows a lot of devices to interact with each other. So here I have designed the UI buttons. Then I write scripts to control variables. Then I pressed test. Then you can see your small aircraft will move according to your input method. The player can move with this first step. And then, the death. The goal usually is to overcome the challenge. It means the player needs to overcome the level that you have designed, but it must be accompanied by the death. You will be able to realize the fun of the game. When the player is attacked or hits a wall, he will die immediately. So let's design some obstacles. To see if we can achieve this goal, fun game. We first create an obstacle in prototype. His behavior is solid. Make sure that after the player hits it, obstacles do not move. Then add some program to the script. If the player has only 1 life, then when the player touches them, it will move the game scene to you lose stage. Here we also use the oncloid and go to layout functions. There are 2 lines of text in this scene. You lose and replay. For the replay, when the player presses it, game stage will return to the playing scene. It can be done by go to layout method. On-touched object. Event is triggered by players pressing an object. We can use on-touched object function because added the touch prototype before, so there's no additional settings are needed. And in C3, there is support for the player to press an object with the mouse and touch panel both. So let's pick one of them that is okay. Let's have a simple test. You can see that when the aircraft collides with an obstacle, then it will trigger the player to death. And then switch to the game over scene. And test if the player presses the replay button. Then you can also go back to the scene you just played. And then challenge it again. Okay, it done in designed of death. Next, if you've ever played a horizontal aircraft game before, you'll know that after the player dropped the coins, they will expect to have at least 3 lives, even if you die due to some minor mistakes. You should also give the player with 2 extra lives. This could prevent players from immediately give up playing the game. So we have to do in the program script is add player's total life count. When the colliding was happen, we should subtract 1 from the life variable. Then determine if this variable is less than or equal to 0. If so, then it really dies. Also, the variable, life, should be reset to 3. When the start of the playing, you can certainly fill in the program directly, integer 3. But I suggest, you should create a default life value variable, first and setting this variable value to 3. After a moment of scene starts. The advantage of this is that if one day you want increases or decreases the default life value, you only need to adjust this variable to achieve this, without having to find this paragraph in a lot of codes. After the small aircraft can be moved, then you have to make it that can shoot bullets. The way the bullets fly is very simple. It just flies from left to right. In designing these little sprite of the bullet, you just need to add the bullet behavior. It could be triggered by buttons. Write down the corresponding script to allow the player to shoot bullets. But here's the thing to keep in mind. The way to judge between button presses, I suggest using, is touching. So that when the player is shooting, just keep pressing the button and don't let go. And you can keep shooting bullets in the period. But if you do a direct test like this, you'll find that the small aircraft is very crazy, shamelessly and wildly shooting bullets. It's like giving him a pair of wings. He can shoot as much as he wants. Of course, that can't be designed like this. You must set the CD time for the bullet to be fired. After the player presses the button to shoot the bullet, you should check if this CD value is less than 0. If it is, then you can shoot it. Then when you have shot, we need to set this variable to the specified CD value. Through another loop, execute every 0.03 seconds. Then during the execution, you should subtract 0.03 from CD variable. In other words, this value we are looking at is in milliseconds. When this value is lower than 0, we will pull it back to 0. This is the same as waiting for the player to be able to shoot the bullet at any time. This design solution will appear many times in this game. You can achieve the concept of cooldown, CD, by this method. By the way, you can use wait time in system tag. It means that how many seconds to blocking. This way can also achieve the CD purpose. But here's a reminder. This feature can sometimes cause non-synchronous waiting to get stuck, and then generates an unintended stop blocking. If you want to use this method to achieve the effect of CD, please try more times before you using it. Okay, just because a bullet can be fired doesn't mean it's over. Because the bullets would be flying to the right, and then C3 will not help you to destroy bullets that are not related to the game. Even if he's out of sight, these little sprites will still be there, if you don't recycle it yourself. Once you're in the game you'll accumulate more and more bullets. It will cause the game to get slower and slower. The second problem is that the enemy on the right side but has not yet appeared. They will be killed in unaccepted. To see this, you can use debug mode. Then you can see that if you don't recycle, the number of dynamically generated bullets is increasing. One day it will slow down your game effect. It should be now. For facing this problem, you need to write some simple scripts. When the bullet hits the red box bar, it will be destroyed. Specifically, this can be done by the destroy function. Using debug mode again, you can then see bullets. It's recycled. So that's what we want. Okay, the bullets are flying out, but not just let fly. We need some enemies to take the heat of these bullets. and they should be shot down. Yes, and then we're going to design the enemy aircraft. In prototype, we have designed an enemy machine. So then the next step is to edit his reaction to the bullets. We don't expect the enemy aircraft to be that vulnerable. So in the prototype, we add the HP attribute in the program. The moment he touched the bullet, that's the moment of on collide. The enemy aircraft will lose 1 of HP. And then the bullet will hit an obstacle. So it would disappear. Also use destroy function. A separate code is also written for enemy aircraft. When the HP is below 0, it will disappear. Next, let's test it. Okay, after the enemy hits the bullet, when its HP goes below 0, it disappears. This is the way we want it to work. This is the first video. If I want to do a horizontal aircraft game design process, we created a lot of layers. Designed the user input interface. Then the player leaves and replay. And handled the movement and shooting of small aircrafts. And the enemy aircrafts that took fire. These should be the first things to be designed at this stage. Later we can modify it by rolling. We can gradually adjust the game experience we want to end up with. But for now, let's just go ahead and explain it here. Digest the whole process. Wait for the next video. And then go to the other optimized design elements. So that's the end of this video. But all this series and finish it. The project will be available at the end of the video. The full version of the game screen and download location can be found in the reference field below. If you have any suggestions, you can leave me a message. If you think it's not a bad movie, please click the like button. And thank you for subscribing to my video. I just wanted to try it out at first. Making the video and then posting it to YouTube is very interesting. But now that someone has subscribed, I've been urged to update the video to some extent. Thank you very much for your support. I will follow up in time. I'll keep updating it as long as I can. Probably not too fast, but I'll try to keep it to 1 video in 2 weeks. Okay, I'm Chung Yi. Thank you very much for watching.